A library functions as an active archive where foundational human ideas and conversations survive across centuries, passing from one generation to the next. Curious, this archive wakes up when isolated ideas across different disciplines finally connect with one another. Long before technology or formal theory, the loop began with raw physical reality. A child balancing a heavy stone on top of another is meeting the world through direct experience. That physical interaction sparks curiosity when the child notices a reliable change, like how a slight shift in weight makes the stack fall. This is the foundation of all intelligence, the act of noticing repetition, difference, and sequence in the natural world. We refine these patterns instinctively. A cook adjusting a recipe based on memory and taste is performing a complex optimization, matching current evidence against past results. Numbers function as the bridge between perception and precision. They are a tool we use to measure the reality we observe. A naturally occurring pattern requires formal mathematics the moment we need to communicate it to someone else. Mathematics was born out of the human need to share and predict these patterns with enough accuracy to build cities and map the seasons. This shared language allows human observations to travel across time and space without losing their specific meaning. Modern systems carry this measurement further by converting abstract human concepts into structured numerical coordinates, or vectors, that a computer can process. This geometric map captures relational patterns mathematically. By placing king, man, and woman in a coordinate space, logic leads directly to queen. This geometric closeness allows a system to predict the next word in a sequence without an internal understanding of grammar. Artificial intelligence is this process of mathematical measurement and geometric mapping scaled to process billions of data points simultaneously. The appearance of human comprehension stems from the high-speed navigation of structured geometry over language. The core pipeline of machine intelligence follows a specific route: receiving input, calculating a mathematical score, making a decision, and then adjusting based on feedback. The improvement mechanism operates by constantly adjusting numerical weights to reduce prediction errors over time. Machine learning depends on processing thousands of game board moves to find statistical advantages, a process rooted in finite rules rather than lived experience. This capability remains strictly bound to numerical relationships. A machine optimizes toward a set objective without the context of a childhood or an ethical framework. While a machine can map statistical territories and predict outcomes, the ability to determine if those outcomes possess human value remains a separate requirement. Intelligence is the ability to optimize a path, while judgment is the wisdom to decide if the destination is worth reaching. AI system outputs function as highly trained guesses based on historical patterns, not absolute authorities. Moral and ethical responsibility must remain anchored to deliberate, slow human cognitive judgment, which serves as the necessary check on fast, automated inference. Deploying intelligence without human responsibility and oversight increases systemic risk. The human duty to oversee consequence, bias, and context serves as the fundamental building block of civilization. As civilization grows in complexity through these tools, it generates entirely new, sharper questions that drive the next stage of human curiosity. Observation, math, AI, and philosophy are all parts of one continuous conversation viewed from different angles. True understanding is achieved when these isolated ideas interact, closing the loop between the child stacking stones and the machine predicting the future. A moment of wonder. The true measure of artificial intelligence lies in what humanity becomes while learning to guide it.